Day 4, we're going to look at polynomials in the form ax squared bx plus c, where a is not 1. And that's the key difference to some of the stuff we've been doing earlier. For this lesson, a is not 1. So put that in at the top. Okay, so the goal of this class is to be able to factor trinomials of this form. So to do that, we're going to first look at the opposite operation, which is expanding. First, we're going to expand. All right, so the steps above, written above, will explain what I'm about to do here. So you're going to take each factor and express them as a length by a width. So 2x plus 3, I would represent that by 2 bars and 3 units. And what should I put vertically down the side for the width? 3 bars and 1 unit, and this unit has to be unshaded because it's negative, right? All right. So as we go through this expansion, when you do the FOIL, you have 2x times 3x. If you were just to do that, what would you end up with? 6x squared. Do you agree? Okay. So now watch my pointer. This one horizontal bar gets times by these 3. So you got 1, 2, 3. Now the other horizontal bar next to it does the same thing. So now this one times these. Do you see where the 6 come from? Now let me go to the green. 2x times negative 1. That's where you have 2 of these bars times this unshaded unit. So 2 horizontal bars get multiplied by 1 unshaded unit. So it's that bar times that unit, that bar times that unit, and you got 2 bars unshaded. Do you agree that that's the same as what you get from 2x times a minus 1? So that's 2 of the sections. Now let me switch color again. I'll switch over to the inside. So now it's 3 times 3x. How do you get 3 times 3x? In the picture, you have 3 little units, colored, times 3 bars. So it's 1 unit by bar, unit by bar, unit by bar, and you get these. So what is 3 times 3x? 9x. That's because there's 3 units times 3 bars. You should get 9. So, and they go this way now. So that's the 3 units times that 1 bar. Now you do it again for the second row. 3 units times that 1 bar. And then it happens again for the third row. Those 3 units times those 3 bars. And you have exactly 9 bars. And then there's only one more step in the expansion. That's the last term. So switch color one more time. 3 times negative 1. So that's these 3 colored units times this uncolored unit. What's 3 times 1? Yeah, and it'll be negative, so negative 3. Now you have to collect like terms. So how many squares do you have? 6x squares. How many bars do you have? Now I have to add the green and the red because they are the same like term. Here was a positive 9x and here was a negative 2x. So altogether that makes positive 7x. And then the very last term is negative 3. Good. So this is the goal of what we need to be able to factor. So let's take a look at this example on the whiteboard. 6x squared plus 7x minus 3. Okay, so I'm just going to pause the video. This is on the whiteboard now. And we're just going to move along. And I'll try to show you how this area diagram connects to the factoring. But for now, we're just going to practice. Can you please practice expanding the first two? Okay, I'm just going to throw up the solution to the first one just to make sure you're doing it properly. 2x by 5x, 10x squared. 2x by 1, that's just 2x. Negative 3 by 5, minus 15x. And then the last one is negative 3 by 1, negative 3. Now the key here is that there's 4 terms in the expansion. That's so important because later what we're going to do is we're going to decompose the middle term using these two special numbers to get a 4-term expression. When you see it, it'll help you later. Right now, let's just keep with the baby steps. Combine the middle terms, what do we get? Negative 13. And then minus the 3, right? So everyone just pause what you're doing, just for a second. What is the AC value for this trinomial? A is 10 and C is, multiply those together, A and C, what do you get? Negative 30. Now what do you notice about positive 2 and negative 15? What do they do that's special? Positive 2 and negative 15, what do they multiply to? Negative 30. And what do they add to? The negative 13. This pattern we're going to have to get used to. One more minute on the second one. Okay. Did you guys get a chance to do the second one? 3x by 2x and 3x by 7. 4 by 2x and then 4 by 7. And then the middle guys can come together, right? 21 and 28 and 8 make 29. And then one more time. Wow, this one's a little bit messy. 28 times 6 is big, so we won't go there. Okay, let's move on. So now, second bullet, we're going to investigate and factor trinomials of the form ax squared plus bx plus c, where a is not 1, using both a concrete pictorial algebra tile approach and a symbolic decomposition method. And like eventually what I want you guys to just be able to do is just the decomposition. That's what I want you to be able to do, but sometimes these pictures help. Okay? Just one last time here before we finally get into it. This is a length, and you're multiplying by a width to give a area. Length times width, area of a rectangle. That's what you're looking for. So here's the question. How could I take all these algebra tiles and make a rectangle? Because that's the goal of factoring. Could I make a rectangle? In other words, i.e., could I factor this? When they ask you to factor, essentially what you're asking is if you could make a rectangle. So if we look at these algebra tiles, how many x squares you got? And how many x bars? 1, 2, 3, 4, 5, 6, 7. And then you got 6 units. It's written right here. Can you guys see this? Okay. So here's the goal. Take the front number, A, and multiply it by the back number, C. What does AC equal? 12. Could you find 2 factors of 12 that add up to 7? And they're on the page, right? 2 factors of 12 that sum to 7. That's what you're looking for. So here we have 3x, and here we have 4x. What is 3x plus 4x? 7x. That's what we started with, right? Now, the reason that you arrange the 7 middle terms into 2 terms, 3 by 4, is so that you have exactly enough room to fit those 6 units. See how those 6 units fit perfectly there? That wouldn't happen if you chose it in a different orientation. Like if you put 5 horizontally and then only 1 row of 2, you wouldn't have room for those 6 units. So it has to work out perfectly, and it all boils down to selecting these magic numbers. And then here's the final answer. Just want you to make sure you notice this. This is the final answer. That's the factoring. So if you go this way, that's factoring. And if you go this way, that's expanding. They are inverse processes of each other. Make sure you understand that. And the goal here, I think being able to FOIL is definitely a required skill, but being able to factor these really will distinguish like the -1 and the -2 sort of stream, if you will. Those that struggle with this, like, it's kind of the writing on the wall. But, I mean, if you struggle with it, keep practicing, obviously. Okay, so this is what we're looking for. I need 2 numbers that add to B and multiply to AC. That's what we're looking for. And on the next page here, just like put a little note here. Start thinking here. Okay? Whoa. Like start with the factors. Okay? Start with the factors because that gives you a finite list that you can work with. So let's take a look at the first one. 6 times 2 is, so I need 2 numbers that multiply to 12 and 2 numbers, 2 numbers that, okay, I apologize. I jumped the gun here. Put this on the side because you need the room underneath. My bad. My bad. Put this on the side. 2 numbers that multiply to 12 and 2 numbers that add to 7. We've seen this one already, so I'm just going to put it in. They are 3 and 4. We've seen that one already, right? Okay, now here comes the reality. I apologize, there's some background from my phone and the microphone. Okay, so use these 2 special numbers to decompose the middle term. So we would change 7x on purpose to 4x plus 3x, and it doesn't matter the order. You could have put the 3x first, it doesn't matter. But we just rewrite the middle term. Why do you think we do that? Because what happens when you FOIL? What happens when you FOIL? How many terms should there be? 4. So if we're trying to undo the expanding, we have to get to a place where there's 4 of them. Right? So that's with symbols. Now check out this picture. Back it up. Look at this picture. How many sections are there? Use my highlighter. 1, 2, 3, and 4. There's 4 sections. So that's why we have to break this down into 4 terms. Now we've done this already last week, so I'll remind you how this is done. When you have 4 terms, you have to put them in pairs. You guys remember that? Put them in pairs. And then you have to grab a GCF. What's the GCF from the first pair? A 2, what else? A 2x, right? You see they both have x in their expression? That one's x squared, that one's x to the 1. So in common, they have at most 1. So you can take out a 2x. Divide each of those by 2x, what do you get? 3x plus 2. Now do you see how we already have 3x plus 2 over there? It's showed up twice. What's the GCF for 3x and 2? Is there a GCF? There's nothing that divides both 2 and 3, right? They're both prime. And this one doesn't have an x, right? So they have no common factor except for 1. So you can factor out a single 1, which changes nothing. When you divide by 1, it doesn't change anything. Now they have a common binomial. Do you guys remember taking out the 3x plus 2 common binomial, and then you're left with 2x plus 1? So imagine like dividing out the 3x plus 2, what would be left over? 2x and positive 1, which go here and here respectively. And that's the factored version. That's your length, that's your width. And it equals the area up here. It's the same. That's the length factor, that's the width factor for this area expression, which is this. This is by far the hardest part of this unit. So if you can get good at this, you're mastered most of the tough stuff. And we're going to go slow on these, like, I'll be patient with you guys. You guys comfortable with the first notes? Okay. 2 numbers that multiply to not just 18, right? 4 times 18, right? And it's negative. And 2 numbers that add to negative 21. Oops, that should be an add. Okay, I'm going to pause the video while you guys brainstorm on these numbers. Okay, so I'm thinking 18 and 3. Am I wrong? Yes, I'm wrong. Did anybody else get this? 24 and 4? 24 and 3. Okay. 24 and 3. Now, which one of those is going to be negative? You see how it ended up negative with the sum? So that means that the negative has to be on the big number, right? Because if you're going to multiply to a negative, one of them's negative and the other is positive. Now what do I do with those two special numbers? I use these two special numbers to break down the middle into a 4-term factoring. So 21a negative will be negative 24a plus 3a. I'm not going to change the front or the back. And it's very important that you maintain organization, maintain your positive, negative, because you have to keep track of everything and you have to be very diligent here. Now, once you have used those special numbers, you've essentially guaranteed that this will work. What's the common factor out of the first pair? 4 for sure, but is there also a variable? One single a. When you divide 4a out of the first term, you'll get a, and then the next term will be minus 6. Because in the first one, the 4's cancel, and in the a2 and the a1 leaves 1a. And in the second one, 24 divided by 4 is 6, and the a's cancel. And then a negative divided by a positive is negative. So the signs will always stay the same respectively if you factor out a positive. Factoring out a positive is good. And looking at the pattern is good too. Like, look at the pattern in the pluses and minuses. Plus, minus, plus, minus. That's a good pattern. When the pattern repeats itself after the first two, that's how you know it's good. You don't have to factor out any negatives. What's the common factor for the second pair? Only a 3, right? Why can't you factor out a? 18 doesn't have a on it. Now when you factor out a 3, this is what most of you will do, and in all my years of teaching this is the one thing, I don't know why you guys refuse to do this, but it's a positive 3. You have to have that plus sign there. It's not a product yet. So if you omit this plus sign, it's, look, this is like 4a times a minus 6 times 3 times a minus 6. We're not there yet. This is still a sum, not a product. So you have to have the sign there. That plus. Don't omit this. Okay, now what do they have in common? What binomial do they have in common? A minus 6. And then you can put in the other two terms, which are 4a and positive 3. Okay, that's the factoring. Starting to get a feel for it? And if you've noticed, the one part that's tough in this is the very beginning. If you can't find those two numbers, are you going to be able to do this? So this is the brainstorming part. This is the thing that, like, if you didn't do well in integer operations and times tables in your early life, this is going to be a bit of a struggle. This you can memorize and practice. This is a skill, like, for the life of me, I could remember a jump shot for the life of me, right? Now, if I suck at basketball, I probably won't hit a bunch, right? I know what I'm supposed to do. I know I'm supposed to be able to do this, but will I sink it? That's where it's tough. So if you're no good at certain skills like times tables or integer operations, you have to figure out that calculator. Okay, know thyself and learn a strategy. Here's the strategy. This is what I would do. It's 72. 72 divided by 2. Look at the two factors. 2 and 36. Doesn't look like it's going to work. 72 divided by 3. Ooh, 3 and 24. I bet that one works. So guess and check your way through a list. That's what I would do. Okay, moving along. Two numbers that multiply to negative 60, 4 times 15. And two numbers that add to 4. So we got them. It's 10 and 6. Which one's going to be negative? So that it ends up positive, right? Very nice. Then we break down the middle term. Which one are we going to put first, 10 or 6? Does it matter? Good. It does not matter. As long as you have the appropriate sign for both. It's a positive 10x and a negative 6x. Because positive 10 and negative 6 for x is the same as 4x. Now you rewrite the front and the back. And then you put them in pairs. Now before we start this one, I want you to look at the pattern for plussing and minusing for the terms. What's the sign of the first two? Positive, positive. What's the sign of the second two? Negative, negative. We need that pattern to be consistent. So if this is plus, this one has to be plus, and this one has to be plus. So this one you have to factor out a negative. This one you have to factor out a negative. All right, what's coming out of the first pair? 2x. That leaves you with 2x plus 5. Now what do you have to factor out of 6 and 15 so you end up with a 2x plus 5? Negative 3. Then those two signs will switch. So factor out negative, so signs match. Factor out negative, so signs match. Now that they have the common GCF, you can factor it out, and you're left with 2x minus 3. Okay, and if you don't believe me, like, FOIL this out. See if you work backwards to get back here, if you don't believe me. Prove it to yourself. Prove it to be true. This one now? I'm going to do this one a little bit differently. I'm going to do the area diagram. I'm going to do the algae tiles without the algae tiles. I'm going to do the algae tiles without the algae tiles. So remember, we break down the middle term, right? So what's this middle term going to be? I'm going to put them in these two boxes once I get it. So I need two special numbers that multiply to 60. 5 times 12 is 60. And then I need two special numbers that also add to negative 32. Does anybody see it right away? Do you guys see it? This was an easy one. You got it, right? 2 and 30, and they're both negative. Negative 2 negative 30, negative 2, negative 30. Now when I decompose the middle term for my algebraic diagram, I'll put negative 30 here and negative 2 here. This is the algebraic way of doing it. So remember we put them in pairs and grabbed a GCF? Do you remember that? In the notes above, you put them in pairs and grab a GCF from each pair. Think of them as rows. What's the GCF for the top row? 5a. So I pull it out this way. Now think about this. What would have to go at this spot to make a 5a squared when you multiply? Yeah. And like, what's the GCF for this column? What's the only thing in common for the first column? A. Okay, well think about this spot. How are you going to make 30 negative when you have a 5a? What do you got to times by? What do you have to times by? 5 times something gives minus 30. What goes here? Negative 6. And then what would have to go here? A times something gives 2a negative. Yeah, negative 2. So the length is a minus 6, and the width is 5a minus 2. That's how you do it with an area diagram. No. Do you prefer the symbols? How many of you actually like that? So you can use your own strategy. But I would say for those of you headed to like a -1, I mean, there's value in practicing the algebra. But then, like, the other part of me is saying there's value in understanding that it's just a length-width diagram. So I see value in both. I think for a lot of students, you know, pick one that works kind of thing. You don't want to overwhelm yourself. Pick one that works. So I'm just going to do it the first way. Something times something is, help me out, 6. Good. Something plus something is -5. This one's not too bad. This one's not too bad. Because like, how many factors of 6 are there? There's not many. 1 in 6 and 2 in 3. You just got to figure out which one's which. What are you guys thinking? Beautiful. -2, -3. I love it. Okay, so split the middle guy. Leave the front and the back. -2x minus 3x plus 3. You know how sometimes you can like change the order of those middle guys? I wonder why I put 2 first and 3 second. I was thinking ahead, wasn't I? 2 will go with 2 and 3 will go with 3, right? They kind of go naturally better that way. You don't have to, but it just kind of looks better. And then one more time on the pattern. What's this term? Plus, minus. So you need that to repeat itself. Plus, oh, it doesn't. So what are you going to need to do on these next 2 terms? Factor out a negative. You have to switch the sign on those 2. Okay, I'm going to write that down here. Plus, minus, minus, plus. That tells you you're going to have to factor out a negative. Okay, so what comes out of the first pair? 2x. I love it. What's left over when you divide out 2x? X and, careful. When they're identical, you're always left with a placeholder of 1. Now, what needs to be factored out of the second pair? What type of 3? A negative 3. And this is so important because when you factor out a negative, that term and that term will switch signs. When you divide by a negative, the signs will switch. That becomes positive, that becomes negative. And now these two binomials match. If you didn't take out a negative 3, you took out a positive 3, would they match? No, and then you wouldn't be able to do the next step. Alright, so factor out the binomial and you're left with 2x minus 3. Okay, and I'll do the area diagram one more time, just for those that were interested in it. So I know I need 4 terms. You need 4 terms. That's from the expansion. So the front we keep, and the last we keep. It's only the middle one we break down, right? So something times something is 15. Something plus something is negative 16. I'll pause the video while you brainstorm on those two numbers. Okay, so the special numbers are negative 15 and negative 1. So I'll change the 16a negative to negative 15a and negative 1a. Now grab a GCF pair out of the first row. What could you have in common in that first row? A 3a. Okay? Now we're pretty much done. What has to go here so that when you multiply this times this, you get 3a squared? A, good. So this is a. Now I'll use my pointer. A times something is minus a. What goes here? Yeah, negative 1. What goes here? You got to get to 15. You're starting at 3. What times 3 gives you 15? Yeah. Negative 5. Now just to double check the last corner, positive 5. Does it make sense? Negative 5 times negative 1 is positive 5? Okay, so then the factors are 3a minus 1 and a minus 5. Whoa. Okay, so choose a method that you like and get good at it. We'll leave this problem for the end. This problem. So let's get a head start on this homework here.